Hi guys, good morning. Yeah, can you hear me? Hello.
Yes.
Yeah. So thank you. So let us start session. Yes. So yesterday's class, all the introduction discussed. Introduction, software introduction discussed. Yes, introduction to software. Yeah, this introduction discussed yesterday. All this introduction discussed. Like what is software? What is system software and application software discussed? Yes, about OS discussed. About OS discussed. Next, about front end, back end discussed. Language package discussed. About languages also discussed. Yes, languages. Yes, low level language, high level languages. Next, generation of computers. About these things also discussed here. Next, about low level, high level languages discussed here. Okay. Yes. See, high level language to binary codes. See, every high level language program has to convert into binary code, zeros ones format. For this, yes, interpreter or compiler. See, either interpreter or compiler converts from high level language to binary code. Interpreter or compiler converts from high level language to binary code. Okay. Yes, interpreter compiler. What's the difference between these two? Let us say about interpreter and compiler. About interpreter and compiler. Yes, about interpreter and compiler. Yes, topic is about interpreter and compiler. What is interpreter compiler? Let's say what is interpreter and compiler. Yes, what is interpreter? What is compiler? See, interpreter compiler both are to convert from high level language to binary codes. Interpreter and compiler both are to convert from high level language to binary code. Both are to convert from high level language to binary code. What's some difference? So what's the difference? Interpreter, compiler, what is difference? Let us see that differences here. So for interpreter, I'm taking Python. For interpreter, yes, for interpreter, I'm taking Python example. Python is a interpreter based language. Python is a interpreter based language. Okay. Python is a interpreter based language. So some test.py, some Python script. Test.py, some Python script. Let's see how Python is working. Yes, let us take some small script. Yes, to understand this, let us see small script about Python script here. So about T drive test folder. Okay, T drive test folder. Yes, here just I'm writing some simple script here. Okay, just I'm writing very simple script. Okay, yes. So interpreter and compiler. So what's yes? Today topic is about interpreter and compiler. Clear? Yes. See, last class all this low level language, high level language, and all the discussed here. Yes, here. Yes, interpreter and compilers are to convert from high level language to low level language, binary codes. High level language to binary codes. Interpreter or compilers. Interpreter or compiler converts from high level language to binary codes. Yes, now Interpreter and compiler. What's the difference between these two? How interpreters and compilers working? Interpreters, compilers working here. Yes, for interpreter. Best example, Python. Python is a interpreter-based language. Python is a interpreter-based language. Yes, Python is a interpreter-based language. Okay, let us say about Python script. Yes, we'll write one simple script. Yes, about D drive. In D drive test folder, D drive test folder. Here, we'll write one simple script, very simple script, Python script. Yes, Python script. Addition, subtraction, and multiplication of two numbers. Very simple script. Very simple script. Addition, subtraction, and multiplication of two numbers. Addition, subtraction, and multiplication of two numbers. See command prompt. CMD. Opening command prompt. Yes, from this we should go to D drive. Yes, D drive test folder. D drive test folder. D drive. So D colon that will take to D drive. D colon that will take to D drive. Okay, DR get that contents. DR shows the DR means directory contents here. DR shows the directory contents. These all are directories. See, directory folder both are same. Directory folder both are same. See, for example, here test is a directory. DR means here it's a directory. Test is a directory. Here test is a directory. Test is a directory. Same thing here. Test is a folder. See this. In D drive is a test folder. It's a folder. Same thing here is a directory. So directory folder both are same. Both are same. See, as per GA graphical user interface is a folder. It's a folder. Folder. Same thing. Character user interface is a directory. Directory. Both are same. Folder directory. So GA it's a folder. Character user interface directory. Folder. Yes, graphical user interface. It's a folder. Character interface directory. It's a directory. Folder directory both are same. Both are same. Yes, both are same. Only terminology difference. Only terminology. In GI calling as folder. In character interface calling as directory. Only terminology difference. Only terminology difference. Only terminology difference. Now, test is a directory. Here, direct test is a directory. So changing directory, change of directory, CD test. CD means change of directory. CD means change of directory. Changing to test changed. SCLS, clear the screen. DR, the test coordinates nothing, empty. Zero files, zero directories, nothing here. Empty. Now, let us write a Python script. Notepad, test.py. Test.py, Python script. Notepad, test.py. Notepad, test.py, some Python script. Yes, opening. Do you want to create new file? Yes. Now, very simple script here. A is equal to 10, for example, here. B is equal to 20. Yes, C is equal to A plus B. A plus B. Just adding two numbers. Adding two numbers. Print. Yes, addition. Print. Addition is equal to, yes, displaying C value. Yes, print addition equal to C value. C equal to A minus B. A minus B. Print. Yes, subtraction equal to C value. Okay, C equal to, yes, A into B. Yes, print. Yes, multiplication is equal to, see, displaying this is A equal to 10, B equal to 20, C equal to A plus B. So first addition, adding two numbers, addition, C equal to A minus B, subtraction, C equal to A and B. Yes, multiplication equal to C. This one. See, very simple script. How the script is working? Very simple script. It's very simple script. So how this script is working? Let us see. How the script is working? Let us see about this. Exit. Yes, now Python. Run it, Python. Yes, see, Python, it's interpreter. This is Python interpreter. This is Python interpreter. Python interpreter working on test.py file. Yes, the source code. Okay, source code. So interpreter working on the source code here. See, now run it here. Run it. Yes, addition, subtraction, multiplication. Okay, this is your Python script. Yeah, this script is called a source code. This is source code. It's a source code. This is source code. This whole thing is a source code. It's a source code. This is source code. This is source code. This whole thing is source code. It's a source code. Source code. Okay. Yes. Now interpreter here. Interpreter working on the source code. Interpreter working on the source code. Yes. See, directly working on source code. Directly working. Okay. See, directly executing, right? Suppose if it is C program, what happens? First checking for errors. C program, first of all, compiler check for errors. If no errors, executes, right? But here, when come to interpreter, it won't check for errors. Directly executing program. Directly executing program. Interpreter, yes. So interpreter, it won't check for errors before going to run here. Directly running here. So interpreter never checking for errors before going to run here. Directly running script here. But compiler, what happens here? First of all, checking for all errors. If no errors, then executes. Okay. Suppose here interpreter based on Python script. Suppose any error comes, what happens? Let us see. Suppose, for example, here. Okay. Suppose here comma missing. Okay. Suppose double quote missing. Suppose here bracket missing. Comma missing. Okay. Yes. Comma missing. Here comma missing. Okay. Yes. Here double quote missing. Here bracket. There are 3 errors, right? Totally 3 errors. Totally there are 3 errors in this. Totally 3 errors, right? Yes. Now what happens here? See. Now run it. Let us run that script here. Yes. Here line number 8 error. So what's happened? So see, any error comes to be stopping here. It's not checking for next error also. It's not checking for next error. See how this script is working. Yes, let us see how that Python interpreter working on the script here. How it's working. Suppose script statements. First statements A equal to 10. First statements B equal to 20. Next statement C equal to A plus B. Next statements print addition. Yes, C equal to A minus B. Next print subtraction. So next C equal to A into B. Yes, print. Yes, multiplication. So this is your script. Okay. Python script top to bottom statements. Python script statements here. First statement, next statement like this. Yes, how it's working. See, interpreter, first of all, checking for the first statement. Suppose first statement is correct. Simply here, first statement is correct. Suppose first statement is correct here. Yes, simply here, interpreter converts this first statement to binary code. Serious ones format. This binary code given to processor. Okay. Binary code given to processor. Okay. See, interpreter checking the first statement. Suppose first statement is correct. Simply it converts into binary codes and given to processor. Okay. Interpreter checking first statement. Suppose first statement is correct. Simply it converts into binary codes and given to processor. Now processor generating output finally. Processor will generate output finally here. It will generate output finally. Okay. So interpreter checking first statement. If first statement is correct, simply converts into binary code given to processor generating output here. See, next statements may be right or wrong. See, next coming statements are right or wrong. See, interpreter never think about next coming statements. See, next coming statements may be right or wrong. It won't think about next coming statements. Interpreter won't think about next coming statements. Yes, if it is correct, first line is correct here. simply converts into binary code, then executes. Checking first line, if it is correct, converts into binary code and generating output here. So next coming statements, right or wrong, interpreter never think about next coming statements. Yes, if the statement is correct, simply converts into binary code, then executes. Next, checking for next statement, checking for next statements. Suppose next statement also correct, next statement also correct, next statement also correct, same process. Next statement also correct, same process, converts into binary codes. Yes, converts into binary codes. Yes, generating output here. Okay. Yes, after checking for next statement, checking for next, suppose something wrong here, something wrong, simply stops. That's it. Any error comes, interpreter stops. Any error comes, interpreter stops. See, the same thing happened here. Interpreter shows only one error. It will not show all the errors. Only one error. Only one error. See this error, right? This error, 8th line error. Actually, there are 3 errors. In script, there are 3 errors. But first error only showing. That means interpreter, any error comes, stops. Any error comes, stops. Now let us correct that mistake here. Yes, see. See, I'm using up arrow key. Command prompt, up arrow key. It will maintain the history of commands. Commands history. Sorry. Yes, up arrow key. Up arrow key. Simply up arrow key. Up arrow key getting all the previous commands. Up arrow key. Previous commands. See notepad test.py. Yes, so this is. See, now let us correct this mistake here. Next mistake. This is next mistake. Correct this mistake. Okay. Correct these mistakes here. Yes, after that, save and exit. Now run again here. Yes, now showing next error. Next error. So here interpreter shows only one error. Any error comes, simply stops. Showing only one error. So only one error. So next error. So next error. So this double quotation missing. Here double quote missing. Double quote missing. Okay. Yes, next. Run it. Yes, next error. So next line, 17th line error here. Okay, like this, only one error. Interpreter shows only one error. Interpreter shows only one error. So closing this is right. That's it. Okay, yes, now save and exit here. Now run it here, run it. Yes, now program executed. That's it. So this is working of interpreter. Okay, interpreter checks line by line. Checking first line, then executing. Checking next line, then executing. Any error comes, stops. Yes, it works. Interpreter checks the program line by line. Interpreter checks the program line by line. Interpreter checks the program line by line and executes here. Any error comes, stops. Any error comes, simply stops. Yes, for the same thing, let us take compiler. Let us take compiler. Okay, for the same thing, let us take compiler. Yes, compiler. How compiler is working? Yes, let us take about compiler here. Compiler. How compiler is working here? Compiler. See compiler. First compiler, I'm taking C program. Okay, I'm taking C program. Okay, suppose test.c. C program. How compiler working here? See compiler checking for the first statement. Suppose first statement is correct. First statement correct. Even correct, it won't convert into binary. Even correct, it won't convert into binary. It won't convert. Okay, checking first statement. So first statement is correct. Even correct, it won't convert into binary code. Then checking next statement. Checking next statement. Suppose next statement also correct. Even correct, it won't convert into binary code. Okay. So compiler checking first statement correct. Next checking for next statement correct. Then checking for next statement. Something wrong. Then checking for next statement also. Checking for next statement. Suppose next statement also correct. Then yes, checking for next statement. Yes, even error comes, go to next statement also. Even error is there. Compiler checking for next statements. So next statements like this. Okay, next statement. Checking for next statements. Okay, checking for next statements. Checking for next statement like this. Checking whole program from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. Compiler checks whole program from top to bottom and shows all the errors. And shows all the errors. See that? Let us see compiler example, C program example. C program example. See, this is C program. C program. This is C program. Get this is a main function. Main function. Save. Yes, compile. Compiling. See, no error. Success. Success. Now run it. First number 10. Second number 20. Same. This program. Addition, subtraction, multiplication of two numbers. Program also same here. Addition, subtraction, and multiplication of two numbers. This is C program. C program main function int ABC. Yes, enter first number. Enter first number. Enter second number. C equal to A plus B. Next C equal to A minus B. C equal to A minus B. C equal to A into B. Right. So this is program. Okay. Yes, compile. Success. No error. Run it. Yes, first number 10. Second number 20. Yes, addition 30. Subtraction minus 10. Multiplication 200. Addition 30. Yes, subtraction and multiplication of two numbers. Okay. Now here suppose some errors are there. Suppose there are some errors. What happens here? Suppose here semicolon missing. What happens here? Suppose here comma missing. What happens? Okay. Yes, here semicolon missing. So print here double quotation missing. What happens? Let us see. Okay, here bracket missing. Now save it. Saved. After compilation, see that error. How many errors totally? 7 errors. Here this is showing 7 errors. 7 errors. So this is showing all the errors from top to bottom. Press any key. Press any key. Press any key. Press any key. See this. 16th line error. Next 22nd line error. See at the bottom. 16th line error. 22nd line error. 27th line error. 29th line error. Yes. Like this errors. 42 error. So all the errors, right? Yeah, this is showing all the errors from top to bottom. Compiler shows all the errors from top to bottom. Okay. Compiler shows all the errors from top to bottom. I hope you understand. Compiler shows all the errors from top to bottom. Yes, let us correct all the mistakes here. Yes, let us correct all the mistakes here. Suppose here semicolon missing. Here double quotation missing. Okay. Yes, here bracket missing. Right? Yes, no. Save it. Yes, overwriting. Yes, compile. Compile it. Still 3 more errors. Still 3 more errors. Still 3 more errors. So here errors. So first these errors, semicolon here error. Okay, next here comma missing. Comma missing. Yes, compile success. Success. See. Save it. Yes, overwriting. Yes, compile success. Success. Yes, no errors. Success heights. Success. Yes, if no errors, what happens here? After correction. Yes, after correcting. After correction of these errors here. After correction of these errors. Suppose everything is fine. Everything is fine. Everything is fine. No errors. Suppose everything is fine. No errors. Then compiler opens another file. Compiler opens another file. It opens another file. Compiler opens another file. Okay. Compiler opens another file. Yes, if no errors, compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom. Suppose if no errors, then what happens? Compiler checks whole program from top to bottom. Whole program from top to bottom shows all the errors. It shows all the errors. Suppose if no errors, if don't have any error, then compiler convert this code. Compiler convert this code into binary code and write into another file. Zeros ones formats. Write into another file. Zeros ones formats. Zeros ones formats. So write into another file. Just write into another file. Okay, zeros ones formats. Write into another file. Just write into another file. Write into another file. Okay, so simply write into another file. Just write into another file. Okay, simply write into another file here. Okay, if no errors, write into another file. So it generates another file here. test.exe file generates. It generates one exe file. This file is a exe file. Compiler checks for whole program from top to bottom. If no errors, generates one exe file there for this here. This complete code, see means the C program, complete code, this complete code converts into binary format and write to another file. This complete code, the C program code completely converts into binary code. A system understand format, write to another file. This result file is exe file. Now this exe file given to processor. Okay, processor taking that exe file and executes. So finally generating output simply here. So the test.exe file given to processor. So processor taking test.exe file. Okay, then executing, generating output simply generating output that here. Okay, what is happening at a time? This program executing. Okay, this whole code converts into binary code. Whole code converts into binary format. Yes, and generates one exe file. Exe means executable file. That executable file given to processor. Okay, processor generates output finally. Generating output finally. Now see this. Let me show practically that exe file. Where that exe file? See, it's a math.cpp. CPP means C++. CPP means C++. C language both are same. For both using same compiler. C language, C++ for both same compiler using CPP, math.cpp. So math.cpp, right? See, backend. C drive. In C drive, TC means turbo C installed here. C drive TC turbo C installed bin folder. Here all the files. That's C program files. All the files. See this. Math. See math.cpp file here. One second. Let me remove that existing files. There are some existing files. Let me remove that. Delete that existing files. Delete it. Yes, this is your math.cpp. So math.cpp. Okay. So this is your C program. Okay. Yes, now see, Alt C, compile, success. Now here, run it. Alt or run. See, when you run this one here, backend something happens. Observe this here. If I run this here, backend something happens here. Backend of this ID, turbo C something happens here. Run it. See here, math. Some application with exe file. See, right click, properties. Okay, properties here. This is .exe, right? .exe, math.exe file created. Okay, so the .exe file created, right? So at the end, yes, .exe extension, .exe file created. After creating .exe file, the .exe file, yes, the .exe file executing now. .exe file created and executing .exe file, then 20. Yes, got it. That's it here. So what happens here? How compiler working here? Yes, let us say about compiler. How this is working here? See, compiler checks whole program from top to bottom. Yes, if no errors, generating binary code. That whole code converts into binary format and write to another file called as exe file. Generates exe file. It generates exe file. That exe file given to processor. So executing exe file at a time. So generating output finally. Okay. Now see this. Now what's the difference between interpreter and compiler? What's the difference observed here? See, interpreter expand in this space. Interpreter expand in this space. Compiler expand in this space. Now what's the difference file between these two here? Yeah. How one writes. First the object file, then next exe file. First object file gets an exe. That is next class. Yes, next topic. Exe file. About exe file. Next topic we'll discuss. What is exactly exe file? We'll discuss now. Don't worry. Exe file also I'll explain now. Okay. Yes. Next topic exe file. Exe file object files also we'll discuss. Now what's the difference you observe here? Yes, in first page, second page difference. First page, second page difference. Yes. What's the difference? What's the difference you observed, guys? Tell me. Interpreter and compiler. Difference between interpreter and compiler. What do you observe the difference here? What do you observe the difference? Okay, Swati, okay, correct. Interpreter stops if any error comes, that's okay. Next, any difference observed here? Some important difference is there. In first page, only one box is there, right? In second page, you're showing two boxes. Then what's the difference? Yes, second box, right? What is that here? In second box, what is this? Yes, come on, guys. In second page, compiler. Yes, see, compiler. In compiler explanation here, second box is there. But interpreter don't have second box, only one box. Second box means what is that? That is exe file, right? Exe file. Exe file is a difference. Main difference. Interpreter compiler main difference exe file. Compiler generates exe file. Compiler generating exe file. See, compiler generates exe file. Here this exe file. Here no exe file. So checking first line then executing immediately. Checking second line executing immediately. So any error comes to be stops. But compile is not like that here. It checks all lines from top to bottom. If no error, generating one exe file. Generating one exe file. Okay, so behind of the C program, exe file created. Exe file created, that math.exe file created, that exe file executed. Yes, it executed exe file. Compiler based exe file executed. Yes, suppose interpreter based what happens here? Directly source code executes. No exe file. See dir, cls, dir, test.py, right? The script executed directly. Source code executed directly here. Executing source code directly. No exe file generating. Yes, no exe file generated. There's no exe file. Exe file not generated. So the difference. Okay. Yes. Now let us compare these two. Yes, points wise. Let us compare these two. And easy to understand. Let us compare these two points wise. Points wise. Let us see one by one. Comparison. Okay. Yes, interpreter. Interpreter versus compiler. Compiler. What's the difference here? Interpreter versus compiler. See, interpreter, first difference. Yes, it checks the codes. It checks the codes. It checks the codes line by line. It checks the code line by line. Interpreter, it checks the code line by line. Interpreter, it checks the codes line by line. Interpreter checks the codes line by line. Okay. Yes, compiler. Yes, checks whole code from top to bottom. Checks whole. Yes, whole codes from top to bottom. Whole code from top to bottom. Okay. Yes, interpreter. It checks the code line by line, checking code line by line, checking code line by line. But compiler, it checks whole code from top to bottom. Yes, next output. Even output generation also line by line. Okay, it generates output. Interpreter generates outputs line by line, line by line. Yes, compiler whole program at a time. See exe file creating, right? Compiler generating exe file. That exe file is executing at a time. So whole program output at a time. Yes, whole program output at a time. So at a time. Outputs at a time. Next difference. See, interpreter shows only one error. Yes, it shows only one error. It shows only one error. It shows only one error. Compiler. Yes, it shows all errors from top to bottom. Yes, it shows all errors from top to bottom. Yes, interpreter. It shows only one error. Interpreter. It shows only one error. But when compiler here, it shows all errors from top to bottom. Compiler shows all errors. Interpreter shows only one error. Interpreter shows only one error, but compiler it shows all errors from top to bottom. It shows all errors. It shows interpreter shows only one error, but compiles all errors from top to bottom. Okay, next difference. Yes, exe file. It does not generate exe file. Does not generate exe file. Interpret it generates exe file. Generates exe file. Okay, next one more here. Yes, interpret directly source code execute. That source code. Python script directly executing, and come to compile here. Back at exe file creates. That exe file executes. Exe file executes. Okay, it executes source code directly. It executes source code directly here. But compiler it executes exe file. It executes exe file. That's it here. So finally generating one exe, that exe file executes here. Interpreter it executes source code directly. Interpreter it executes source code directly. It executes source code. Compiler it executes exe file. Okay, see compiler generating exe file and executes. Generates exe file, executes here. Compiler no exe file, don't have exe file. Directly source code executes. Okay, right? Yes, next difference. See, interpreter based languages are called as scripting language. They are scripting languages. They are called as scripting languages. Interpreter based is a scripting language. Interpreter based languages are scripting language. They are scripting languages. Okay. Compiler based languages are called as programming language. They are called as programming languages. Okay, so interpreter based languages are scripting languages. Compiler based are programming languages. Scripting languages and programming language. Yes, all interpreter based languages called scripting languages. Yes, examples, scripting language examples. See, Python is a scripting. Yes, scripting language. Python is scripting language. HTML is a scripting language. JavaScript is a scripting language. JavaScript. Okay, next PHP is a scripting language. Yes, next Perl is a scripting language. Linux is shell scripting language. A scripting language. Okay, programming language example. C language, C++, and .NET, C Sharp. Okay, right? So these are interpreter based languages. Example, compiler based examples here. See, finally some conclusion. See, interpreter based language don't have exe file. See, interpreter based language, yes, don't have interpreter based language don't have exe file. Interpreter based language don't have exe file. See, interpreter based language don't have exe file. See, interpreter based language don't have exe file. Okay, yes, compiler finally generates exe file and executes exe. So everything is exe file here. Everything finally it's exe file. Everything is an exe. Everything converts in exe. Here. Yes, every file. Yes, every program. So every program converts into exe. Every program converts into exe. Exe file. Converts into exe file. That's it. Okay. So this is difference. Interpreter compiler differences. One second, let me have some water. So this is difference. Interpreter compiler. Interpreter line by line compiles whole program. Okay. Interpreter shows only one error. But compiler shows all errors. Compiles all errors from top to bottom. Okay. Yes, interpreter does not generate exe file. Yes, compiler generates exe file. See, fourth and fifth point, they are important differences. Yes, interpreter does not generate exe file. Compiler exe file. Yes, it executes source code. Yes, compiler exe file executes. Okay, next, see 8 points. Finally, conclusion 8 points here. See, interpreter based language don't have exe file simply. Any interpreter based language don't have exe file. Any interpreter based language don't have exe file. Yes, compiler based language converts in exe file, then executing. That's difference. Exe file is a difference. Yes. Now here you guys are getting doubt. See, you guys are getting doubt. Yeah, this trainer, Mr. M.N. Rao, explaining about all this, but he's not talking about Java. Yes, maybe somebody is having this doubt 100%, getting this doubt here. Yes, he explaining about Python and JavaScript and C, C++, many things. Explaining about compiler and interpreter for Java. Yes, Java. Is it interpreter based or compiler based? Yes, now let us start Java. Now I'm starting Java. Yes, entering into Java now. Okay, first introduction, after that Java installation. Okay, writing program and all this here. So first let us start with Java here. Let us start Java. Now here Java. Yes, is it interpreter based or compiler based? Yes, Java. Java. Yes, interpreter based. Yes, Java. Yes, interpreter based or compiler based or compiler based or both. Okay, yes. Now, yes, now you have to answer this question. See, first of all, I'll explain topic, then you decide it. Okay, yes. First of all, I'll explain about Java, how Java is working. I'll explain very clearly. I'll explain about Java very clearly. You decide it finally here. Is it interpreter based and compiler based or both here? Yes, you have to answer. That question you have to answer. I'll explain about the Java here. I'll explain about Java. See, other languages except Java. Other language except Java. What happens here? Source code converts into binary code. Other language except Java, source code converts into binary code. That binary code given to processor. So processor executes on generating output simply. This is what is happening except Java. Except Java in other language, source code converts into binary code. Okay, suppose if it is Python, interpreter converts source code to binary code. Suppose C language, compiler converts source code to binary code. Okay, suppose HTML, in HTML, yes, interpreter converts source code to binary codes. HTML browser is a HTML interpreter. Browser is a, yes, HTML is a browser understandable language. HTML, hypertext markup language. So HTML is a browser understandable language. HTML is a browser understandable language. Okay, right? So browser is an interpreter for the browser. Browser is an interpreter for the HTML. Okay, right? Yes, source code to binary codes, converting by the interpreter or compiler. Okay. Yes, either interpreter or compiler. Only one thing here. Interpreter or compiler here. Okay, C language compiler. Suppose Python script interpreter, HTML interpreter. Suppose C++ compiler like this. Now come to Java. Yes, in Java, what happens here? Let us see about Java. In Java, what happens here? So first of all, source code. Yes, source code converts into bytecode. First of all, source code converts into bytecode. That bytecode converts into binary code. That binary code given to processor. So processor finally generating output. Okay. In Java, what happens here? Source code converts into bytecode. Bytecode to binary codes. That is given to processor generating final output here. In Java, what happens here? One more code introduced here. Some intermediate codes. Yes, it happens in 2 steps. Except Java in other language except Java. Yes, only one step. Only one step. Only one step. But in Java, two steps. First step, source code to bytecode. Second step, bytecode to binary code. Okay, source code to bytecode. Next, bytecode to binary code. It happens in two steps. It happens in two steps. It happens in two steps here. It happens in two steps here. Okay, source code to bytecode to binary code here. Yes, in Java, bytecode is what is introduced here. Some intermediate codes, bytecode introduced here. So why bytecode introduced here? So bytecodes. So bytecodes in Java, bytecode introduced, bytecodes introduced. Okay, to make Java as independent platform. To make Java as independent platform, independent platform. Okay, yes, to make Java, yes, bytecode introduced to make Java as independent platform. For that reason, we'll discuss. Yes, one second. For that reason, introduced here. So bytecode introduced to make Java as independent platform. Yes, to make it as independent platform. Okay, what is independent platform? What is bytecode? We'll discuss. We'll discuss. Wait. Okay, how Java made as independent platform? We'll discuss. Next topic. Independent platform. Next topic. Okay. Yes. Now what happens here? Source code to bytecode. Source code to bytecode. Here this part by the Java compiler. This part by the Java compiler. Next bytecode to binary code. Bytecode to binary code by the Java interpreter. Java interpreter. This part is by the Java interpreter. Source code to bytecode by the Java compiler. Source code to bytecode by the Java compiler. Bytecode to binary code by the Java interpreter. So Java compiler, next Java interpreter here. See, first part by the compiler, second part by the interpreter here. Okay, let us see Java example also. Let us see Java program. D drive, test folder, refresh, nothing, empty, folder is empty. Yes, D drive test directory. Yes, sorry, directory. Yes, sorry, DR. See, 0 files, nothing. Now let us write Java program. Yes, notepad, test.java, notepad test.java. Java, yes, creating new file. Yes, simple Java program. Yes, public class, test, tcaps, starting, ending. Okay, yes, public, yes, static, public, static void main methods. Public static void main methods. Main method string. Yes, string square bracket dogs. Okay, yes, system dot how dot println. Yes, here it's a hello world, closing main. Okay, see, public class test, public static void main, string square bracket dogs. System dot out dot print. Yes, about the Java program next we'll discuss. Topic is not about Java program. Topic is about compilers and interpreters. Okay, what is public, what is class, what is a Java? About Java program, we'll discuss after installation. So next topic is Java installation, writing Java program. That time we'll discuss about this program here. So this is not right time to discuss about Java program. Now topic is about compiler and interpreter. Topic is about interpreter compiler. Okay, save it here and exit. Not dir. See this test.java file. Now let us compile it. Java C test.java. Yes, compiling. Compiled. Yes, compiled. No error. Yes, if no error. Yes, one tested dot class file generated. Dot class, it's a bytecode file. Dot class a bytecode file. Test.java is a source. Test.java is source, which is a source file. Source file converted into bytecode file. Okay, so what happens in Java here? See, in Java, what happens here? See, so first test.java, test.java is given to Java compiler. So test.java is a source. It's a source. It's a source code. It's a source code. Test.java, it's a source code. Test.java source code. The source code given to Java compiler. Java compiler. Okay, result is tested dot class. Tested dot class, right? What is dot class? It's a bytecode. What is bytecode? I'll explain. Just wait. In Java programming, we'll discuss. About bytecode, we'll discuss in Java programming. Bytecode we'll discuss next. Wait. Okay. Test.java. It's a source code. And compilation result is dot class. Dot class is bytecode. Now this bytecode for test.class will given to Java interpreter. Java interpreter. Yes, it's given to Java interpreter. So it's given to Java interpreter. Interpreter. Okay, Java interpreter, right? Java interpreter. Java interpreter. Yes, Java interpreter converts that bytecode to binary code now here. See, first test.java taken by Java compiler. Check it. Finally generated dot class file. Okay, it's a result of Java compiler. Java compiler generates dot class file. It's a bytecode. Okay, that bytecode given to interpreter, Java interpreter. The Java interpreter converts bytecode to binary code. Now converting to binary codes. It converts into binary codes. Binary codes. Binary code given to processor. Processor generating output finally. Processor will generate output finally here. Processor generating output finally. That's it here. So what is happening here? Source code to bytecode by the Java compiler. That means errors. See, in Java, errors checking by the compiler. Okay, errors checking by the compiler. See, in Java, errors, all the errors checking by the compiler. Okay, in Java, errors checking by the compiler. Yes, if no errors here, then generate dot as well. Generates bytecode file. Generates bytecode file means dot class generates. Generates dot class file. Generates dot class. Okay, in Java, yes, in Java errors checking by the compiler. Java errors checking by the compiler. Yes, if no errors, generates bytecode with dot class file generates. So errors checking by the Java compiler. Okay, errors checking by the Java compiler. So Java C means Java C. It is Java compiler. Program compiling by the Java C. Okay, Java C test.java. Java compiler. 1 second. See, just for understanding purpose, I'm using Notepad and command line, but in real time it's a Eclipse. Yes, actual classes using Eclipse only here. Everyday class with Eclipse I'll explain. Eclipse. See, everyday class, daily class in Eclipse. Okay, daily class never using Notepad. So daily classes topic here, not using command prompt or Notepad. Okay, our daily class is completely Eclipse. Completely using Eclipse here. Only for understanding purpose. Here one example explaining here. Understanding purpose. This is Eclipse IDE. Here this Eclipse, how to install Eclipse, tomorrow topic. This Eclipse installation. Tomorrow going to discuss. This Eclipse topic tomorrow will be discussing. Tomorrow about this Eclipse topic. Okay. Tomorrow about this Eclipse topic here. Installation, Java and Eclipse installation tomorrow. So our daily classes using Eclipse. Now, see Java C test.java. Java C test.java means it's compiling. It's a Java compiler. So first of all, compiled. After compilation, then execution. If dot class file executing. Yes, execution. For execution, dot class is not necessary. For execution, dot class is not necessary here. Tested dot class. Extension not necessary. Extension not necessary. Then you can submit. See, Java C means is Java compiler. Here, Java test means what is this Java here? What is Java? It's a interpreter. It's an interpreter. Java C, it's a compiler. Java, it's an interpreter. Java C compiler. Java, it's interpreter. So errors checking by the compiler. If no errors, generating dot class file. The dot class file executing by the interpreter. Dot class file executing by interpreter. Okay, in Java, errors checking by the compiler. If no errors, then generates bytecode for dot class file. Okay, right? Yes, Java program. Yes, next Java program dot class file. Dot class file. Dot class file executing by the interpreter. By the interpreter. By the interpreter. By the interpreter. Okay, so what is happening here? Yes, here compilation process. Compilation process by the yes compiler. Error checking by the compiler. Error checking by the compiler. Okay. Yes, in Java, errors checking by the compiler. If no errors, errors checking by the compiler. If no errors, generating dot class file. Dot class file. Okay, the dot class file program executing by the interpreter. Okay. So what is happening here? Source code to bytecode by the compiler. So this part by the compiler. Bytecode converting to binary codes by the interpreter, right? Okay. So this first part, source code to bytecode by the compiler, bytecode to binary code by the interpreter, finally generating output here. Now, tell me. Now Java depends on what? Yes. Now we should answer this question here. We should answer this question. Yes. What is Java? Yes. Is it interpreter based, compiler based, or both here? Come on, guys. Tell me. Now, what you understand? As per this understanding, as per this understanding, what is Java? Is it compiler or interpreter based? What you understand now? Tell me. What you understand? Is it compiler based or interpreter based or both? Hello, please respond. Yes, is it compiler or interpreter or both here?
Both.
It's a both here. Yes, it's a both. So Java depends on both. Java depends on both. Both interpreter and compiler, both are involving here. Two things are involving here. So interpreter as well, compiler here. Okay, Java depends on yes, Java depends on both. Java depends on both compiler as well interpreter, compiler as well interpreter. That's it. Java depends on both. Okay, Java depends on both compiler as well interpreter. Java depends on both compiler as well interpreter. Java depends on both compiler as well interpreter. Okay, I hope you understand, guys. Okay, next one more point. Yes, here one more point here. See any language. Try to understand this point here. Any program, any language program executing by the means runtime. Program execution means runtime. Any language program execution by the interpreter execution by the interpreter don't have exe file. Yes, don't have exe file. Interpreter based language don't have exe file. See any language program executing by the interpreter. Any language program executing by the interpreter don't have exe. Okay, so any language program executing by the interpreter don't have exe file. Any language program executing by the interpreter don't have exe file. Okay, see interpreter based language don't have exe file, right? Interpreter based language don't have exe file. Okay, so any language program, maybe Python or C program or C++, whatever it is, maybe Java. If program executing by the interpreter don't have exe file. Now here's some question for you guys. Now some question. Can we create exe file in Java? Yes, it's an interview question. Yes, anyone can answer this as per our explanation, as per this last explanation. Tell me, can we create exe file in Java? Can we create exe file in Java? See, Java programs step by step explain here. So first word notepad, source program, right? Source program tested.java file. dot Java file, dot Java file. After that compiled, Java C test.java compiled. After compilation, result file is dot class file. Dot class is not exe file. Exe file is different, dot class file is different here. Next, after the executed dot class file, test dot class file. Test dot class file executed. Yes, in this process, have you observed any exe file? In this whole process, okay, writing, compilation, then execution. In this process, have you observed any exe file? In this process, writing program and compilation and execution. In this whole process, have you observed any exe file? No, no exe file. Here is not observed any exe file. See, dot class is not exe file. Dot class is different, exe is different here. Dot class file is different, exe is different. Dot class is different, exe is different here. Don't have exe file. Okay. Next, one more thing, one more point. Yes, we mentioned here. One more point I mentioned here. Interpreter based language don't have exe file. Interpreter based language. See here, interpreter based language. See any language program, executing by the interpreter don't have exe file. No Java program execution by which one? Compiler, interpreter. Java program execution by the interpreter, compiler. Java program dot class for executing by the interpreter. Java program dot class for executing by the interpreter. Yes, since Java program a dot class for executing by the interpreter don't have exe file concept here. Yes, no. Answer is no. There is no exe file concept in Java here. No concept of exe files. Okay, so here no concept. Yes, no concept of. Yes, no concept of exe files in Java. No concept of exe file in Java here. Yes, reason here. Yes, since Java program dot class for executing by the interpreter. Yes, don't have exe files. Don't have exe file concept. Don't have exe file. Okay, don't have exe file. Since Java program dot class file executing by the interpreter. Since Java program dot class file, the dot class file executing by the interpreter don't have exe file. Don't have exe file. So yes, no concept of exe files in Java. Okay. Yes, in Java everything is dot. In Java, see in Java everything is a dot class file. Everything is a dot class file. Java everything is dot class file. Everything is dot class, but dot class file is not exe file. Dot class file is not an exe file. Is not an exe file. Dot class file is not an exe file. Dot class is not an exe file. Exe file is different. Dot class file is different here. See exe file. Exe file is a binary code 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 file. Yes, and it is a system understandable language. System understandable language. Understandable language. It's a system understandable language. It's a system understandable language. It's a system understandable language. Okay, it's a system understandable. See, exe file is a binary code file. Exe file is a binary code means system understandable language. What is dot class file? See dot class file. See dot class file. Dot class file is a bytecode file. Bytecode file, and it's a JVM understandable language. Yes, what is bytecode? We'll discuss in Java. Once Java programming started, we'll discuss about bytecode. How that bytecode executing with the JVM? Yes, we have separate topic on JVM. That also we'll discuss. Dot class file is a bytecode file and it's a JVM understandable language. JVM understandable language. Next, one more here. Yes, exe file is a OS dependent. Exe file is a OS dependent. So whereas dot class file is an independent of OS. Is an independent of OS. Okay. See how dot class file made us independent of OS. Independent of platform, that features we should discuss. Okay, that will take minimum 1 hour class, more than 1 hour class. That is The topic after installing Java we'll discuss. Okay. Yes, in tomorrow class, Java installation, Eclipse setup. So once you write the first program, then we'll discuss about independent platform. So once after installing Java, after installing Eclipse, we'll write one program. Then we'll discuss about independent platform. You can understand very clearly. Okay. So next topic is about Java installation and Eclipse setup. Java installation and Eclipse setup. 1 second. Let me save this one. This file. Yes, I'll share in group. This is DTM. Yes, interpreter compiler. Yes, it's a yes day 5. No, actually day 4 topic. One day topic repeated. Day 4 topic only. Right. I hope you understand, guys. Right. Interpreter compiler differences. Is it clear? Everyone? That compiler interpreter clear? Java
Yes, sir.
depends on both compiler as well interpreter. Yes, interpreter compiler. I hope everyone understand very clearly. Okay. Yes, I think my class are very clear, right? Very clearly and easily understanding, right? My classes. My class are easily understandable. Okay, see, compared to any trainer, my classes, easy explanation, easy understand, no doubts. Okay, no doubts. Yeah, today day 5. Yes, today day 5. Yes, what's happened here? Day 1 topic repeated second day on second day. See, Monday topic repeated. Monday 29th topic repeated. Sorry, Monday topic September 30th. So Monday, the 26th topic repeated on 27th. So 27th is day 1, 28 day 2, day 3 day 4. It's a day 4 today. Okay, actually started on 26th, but 26th topic started on 27th. Repeated. 26th topic repeated on 27th. So 27th is the first class now. 28th, 20 and 30. Okay, so this is yeah. So as per batch starting is a day 5. As per topics is a day 4. That's it here. Okay. Yes. Today day 4. Yes. Today day 4. So as per topic is a day 4. Yes, whatever it is, day 4, day 1, day 2, day 3, whatever it is, topics are going on. Okay, topics are going on continuously here with link step by step going on. Okay. Yes. Tomorrow Saturday class Java installation. Tomorrow Java installation and Eclipse setup. Tomorrow I am taking Java installation Eclipse setup. So Sunday will be getting time. Sunday will be getting time. Sunday will less time to for installation. Okay. Yeah. Eclipse don't have a. Okay, 1 second. Let me check it. Yes, I will drive. Yes, I think Eclipse. Yes, I think someone has removed Eclipse. Yes, even yesterday one more guy also asked me about Eclipse. Yes, M1 Java. Yeah, don't have Eclipse. Yeah, let me upload Eclipse. D drive, C drive, Eclipse. Yes, I'm putting into drive, uploading drive. Yes, in drive, all these things available. Yes, tomorrow we'll discuss. Tomorrow we'll discuss. So how to download from the drive, how to install, how to set up. Tomorrow I'll clear that. So once cleared, you can start installation. Okay. Yes, in Visual Studio Code also you can write. You can write, but that's not recommended. Visual Studio Code is recommended for Microsoft applications like .NET, and Python code. Yes, Python code projects and .NET code we can write in Visual Studio Code. Java also we can, but that's not recommended. Java Eclipse is recommended. Java, most of the companies, 99% of companies using Eclipse. Rare case using IntelliJ. We have one more ID, IntelliJ. IntelliJ also using for Java, but rarely using. But Visual Studio Code never using. Visual Studio Code never using for Java. Java recommended. Yes, it's a Eclipse always. Eclipse. See, with Eclipse here, many advantages. With Eclipse, many advantages. Mainly here, code generating. That Eclipse generates some code automatically. If using Eclipse here, if you are using Eclipse here, 60% of Java codes. Okay. Yes, 60% of Java code generating with Eclipse. Suppose if using IntelliJ, yes, if using IntelliJ here, we should write every code. IntelliJ don't have the option for the auto-generated code here. Okay, IntelliJ don't have auto-generated code option. Okay, next Visual Studio Code also don't have auto-generated code option. Only Eclipse is having auto-generated code option. So with Eclipse, yes, 60% of code will be generating automatically. Only 40% we should write. Okay, right? Yes. So IntelliJ mostly using for the IntelliJ mostly using for the big data development. Yes, Scala application generally using IntelliJ. Scala. Yes, in our Java projects we are using Scala. Okay. Yeah, Angular Visual Studio Code you can use. Okay, Angular you can write, you can use Visual Studio Code, Angular. Okay, yeah. So that's all about interpreter and compiler. Okay. Yes. Still any doubts? See, here, yes, for our batch WhatsApp group created. In WhatsApp group, I'm sharing everything. Yes, I hope everyone is WhatsApp group. Everyone is in the WhatsApp group. Yes, who are attending classes, everyone in the group here. I'm sharing all things in WhatsApp group. Yes, almost two. Or even drive access also. Drive access also given to everyone. Okay, except 1 or 2 guys, everyone paid. Yes, in your batch, 12 members registered already paid 12 members. For all paid members, I have shared. I think only 1 or 2 guys were left. Okay, yes. Yes, tomorrow we are going for Java installation. Yes, by tomorrow class, yes, download by tomorrow class, download Java and Eclipse from your drive. Okay, drive then ready with the installation. So this is ATM. Yes, see this yesterday's recording. Yeah, day 4 session 4 recording shared. Session 3 recording shared. Okay, up to date recording shared. Even document also day 1, day 2, day 3. Yes, all the documents. So today day 4 documents. I'll share it. Today day 4. I think it's saved interpreter compiler day 4. Java 18. Yes, day 4 interpreter versus compiler. Day 4 topic. Yeah, day 4 shared here. Yes, recording within 1 hour I'll share it. Recording within 1 hour I'll share it. Recording also. Okay. Yeah. Yes, still anyone not in WhatsApp? Yes, if anyone not in WhatsApp, this is my WhatsApp number. Yes, 81789189. Okay. Yes, your name. Next WhatsApp course you are attending here. Next WhatsApp time you are attending here. Next, what is your Gmail? This is I want details here. Yes, still anyone not in group, share this one. I'll add to group. Share it. I will add to group. That's all for today. That's all. Yes, tomorrow. Yes, tomorrow we'll continue for Java installation. Okay. So thank you guys. Thank you guys. Yes. Have a great day. See you tomorrow. See you tomorrow. Have a great day. Tomorrow also same link. Tomorrow also same. No change in link. Tomorrow also same link.